there you go. I think the answer for number 1 should be 11. The answer for number 2 should be x is greater than or equal to 2 with the coordinating graph. And then number 3 is a graph line. Okay, do you guys have any questions on your DMR? Yesterday you guys had lots of good questions on this. Maybe you've got those all figured out, maybe not, whatever. Anything I can do to help you guys? Sydney. You're talking about number 2? So yes, if I showed you a couple steps on number 2, let's see if, I'll try to accommodate your steps. Did you add 5x to both sides? Okay, so I think that's a fine move. So if you add 5x to both sides, you get 11. Oops. $11 is less than or equal to 7x minus 3. You probably added 3 to both sides? Okay, so if you did that, you end up with, and I'll just come over here, 14 is less than or equal to 7x. And then I'm guessing you divided by positive 7. Okay, so that's perfect. So then you end up with 2 is less than or equal to x. And so I feel like you maybe, did you plot the 2 and then draw arrow left? Okay, so I want you to think about this for a second, and we'll come back around to like why we want to write it the way we want to write it. So if you put a solid dot there, and then you drew arrow left, that means all the numbers to the left should work, right? They should make the inequality true, but I think that you'll find that none of them do. So if I just picked one of them out there, maybe like 1, and I plugged it in right here, wouldn't I get 2 is less than or equal to 1? Is that true? Of course not. And you can see that if I tried any of those other ones, I'd end up with a similarly false statement. So it's not about flipping the inequality. It really is not. What it's about is saying the inequality in a, like what I call standard form or a standard way. It's kind of like what I said yesterday. Like there's lots of different ways to say things. Like I could say, later on today, I will eat lunch. And you'd all say, great, yep, me too. What if I said, eating lunch is something that I will be doing later on today? Wouldn't you look at me and say, well, you sort of said that weird, right? It's like said in kind of a backwards way. Like, hey, our football team's going to try to win the game on Friday. Versus winning the game is the goal of our team. It's like, I'm saying the exact same thing, but I'm saying it in a backwards kind of weird way. To me, the way that that's currently written up there is a weird backwards way. The standard way, the way that's going to make it easy to graph, is to always have the x on the left side and then the number on the right side. So if I decided to write it the other way, I would put the x over here. And wouldn't the alligator that y'all learned about in middle school, wouldn't it still be eating the bigger thing? So the alligator would still be eating the x. No matter how I write it, that alligator is going to be chasing after the x. So if I want to say it the normal way, the standard way, I would say x is greater than or equal to 2. That tells me that I should draw my arrow to the right. And now if I tried some of the numbers off to the right, like 7, and I plug it in, 7 is greater than or equal to 2. True. 5 is greater than or equal to 2. True. And so all those numbers actually do make sense. They do make it true. So, but I think it all comes back to, are you going to say it the weird way or the normal way? So, great question. Thank you so much for asking. Anybody else have any sort of a question like that?
I forgot which one is a closed and which one is an open circle.
For sure. So if you look at your inequality, that'll tell you what you need to know. If the inequality has the little or equal to, and I'll try to draw an arrow in there, that little horizontal line, if it's got the or equal to, that means we're going to include our number.
Okay.
If it does not have the or equal to, that means open circle, which means we're not going to include, in this case, the 2. A cute way I learned a long time ago is if you have to take extra ink to write the inequality, like the little extra line, if you have to use extra ink there, you got to use extra ink on your dot
Okay.
and make your dot filled in.
Okay.
That's one way of thinking about it. Anybody else? Thank you both for asking, but is there another one? Okay, cool. I'm going to take you guys through a little exercise here. I'm actually going to go back in my pack a little bit. You really don't have to do this. We're going to do this one together. While I'm doing this, I want to let you guys know that on Friday of this week, our final meeting of this week, we'll be starting a 2-day in-class project. I am super stoked to see what you all do with it. It's going to be super interesting, hopefully creative and fun. The one thing you will definitely need to have in class with you is some kind of an electronic device, preferably for your sake. If you have an actual computer, that would be best. What we're going to do could be done on a phone, but the computer is by far going to be the easier tool for you. So if you've got a computer, bring it. If you don't have a computer, but you do have a phone, bring it. You're going to need it. Like not having it, you are just going to be completely out of luck and you're going to be doing a ton of work at home. Bringing your electronic device will mean that you can do a lot of it, if not all of it, here within our classroom. Fair enough? You good? Okay, so here's the exercise I want to do with you guys. So just take a look at these two right here, lines A and B. One's red, one's blue. Lines A and B appear to be, which one would you choose? Parallel, perpendicular, or neither? What would you say, Bree? Parallel. Do you all agree with that? I think that's a fair answer given the way those two lines look. So just looking up there, and you don't have to turn back to these if you don't want to. This is just a quick exercise to get us warmed up. Looking at those two lines, what would you say is the slope of line A? What would you all say is the slope of line A? You don't have to turn back. I mean, those of you that are getting busy doing that's okay. It's one more page, but yeah, just look at the string. Line A. What would you say that is? Is that what would you say the slope of line A is? What do you think, Sophia?
2.
Wouldn't it be 2? Let's test it out. So if I looked at the line A, would you agree with me that this point is on the line? And would you also agree with me that this point is on the line? How do I get from one point to the next? Wouldn't I have to go up 2, right 1? So I think the slope of 2 makes a lot of sense. How about the slope of line B? What would you say to that?
It's the same.
It's the same, so you think it's also 2?
Yeah.
I got 2 points already marked on there. Couldn't I just count from this gray point and go up 2, right 1?
Yeah.
So I think a slope of 2 for line B also makes a lot of sense. So what's our conclusion? I'll start you off here, and I will say if lines are parallel, slopes are
Same.
the same. Or in math, what do we use for the same?
Equal.
Equal, yeah. So if the lines are parallel, the slopes had better be equal. And that's the conclusion. That would be the takeaway here. And I think you can see that visually. The slopes indeed look very much the same. Okay with that? Let's do one more similar idea. Look at those two lines. Lines C and D. I'll label these for you because somehow the label got lost. So I'll call this line C and this line D. So do these lines appear to be parallel, perpendicular, or neither? Well, perpendicular lines form what kind of angles? Right angles or 90-degree angles. Do that angle right in there, does this angle look like a right angle?
Yes.
Wouldn't you have to admit that it's at least sort of... Yeah, right angle. Wouldn't you agree that it's at least sort of close? I mean, I don't think you can look at that and say, no, Mr. Anderson, it's 78 degrees. Or it's 89 degrees, right? Wouldn't you have to say it's like at least it maybe looks perpendicular? I hope you would say that. We'd say perpendicular. Let's explore the slopes. What would you guys say the slope of the red line is? Slope of the red line.
1/4.
Say again?
Well, if you're going, you go up 1, but then you go over 4.
Okay. So, by any chance, did you use this point to help you?
Yeah.
And what was the other point you used to help you? The one to the right or left?
The left.
One to the left, okay. So, would you agree with Issa that those 2 points are on the line?
Yes.
Okay. So, let's see here. The rise and the run. So, to go from one point to the next, I would have to go up 1. And wouldn't I have to go left 4? Yeah, and so overall, isn't this red line heading downhill? So the slope has to be what type of thing? It's got to be negative. So if you said negative 1/4, I think we're on the same page. So slope of line C, negative 1/4, I think makes perfect sense. How about the slope of the other line, the blue one? What do you see going on up there? Mason, what do you see?
I said it was up 4/1.
Up 4/1, so that'd be a slope of? 4. Okay, so Mason, I don't know, did you use this point to help you?
Yeah.
And which other point did you go up and right or down and left? To get to that next point.
2, 0.
Say it one more time.
The below 0.
The below 0 one?
Yeah.
So over here?
Yep.
Yeah, that one? Okay, cool. So I'm guessing what Mason said, he said up 4, right 1. Makes a lot of sense. This was a little bit harder. So these lines are indeed perpendicular. So if we had a conclusion here, and I said perpendicular lines have slopes, I'll put it like this, have blank slopes. Could we fill in the same word we did before? Do perpendicular lines have equal slopes? You can tell they're different, right? One of them is 4 and the other one's negative 4. You know what? The word opposite is quite important. So we're going to say that perpendicular lines have opposite. But it's not just that they're opposite, because opposite just means the negative. And it's not just that one of them is positive and the other one is negative. Something else has happened, right? Okay, what kind of inverse? Because I agree with you, inverse could be used here. Oh, yeah. So she says multiplicative inverse. I'm going to use this word instead. This is the same meaning of what Julia just said. Have you ever seen this word before? Reciprocal. So doesn't reciprocal just mean take the fraction and do this? Just flip it. So it's the opposite reciprocal slope. So the reciprocal of 1/4 is 4. And the opposite of that would make it negative 4. Anyways, let's see if you guys can say this. Parallel lines have equal slopes. Parallel lines have equal slopes. Perpendicular lines, though, their slopes are opposite and reciprocal. Yep, they're both. Okay, cool. Let's see here. Let's keep working. I'm going to jump around a little bit. I want to do, let's see here. We did this yesterday. I want to do, here's 15. I want to review this with you. So we didn't do this one yesterday. So go back one page from your DMR. Just go back one page to number 3. This is what we finished with last time. And I want to tie this in here today. Get things wrapped up here in a second. Okay, so let's see how much we can remember and recall from yesterday. So I'm going to ask you a question. If I'm trying to graph a line, or if I'm trying to write the equation of a line, I need to have 2 things, right? If I'm trying to graph a line, or if I'm trying to write the equation for it, I got to have 2 things. What are those 2 things? So I'm going to agree with your idea of slope. but the y-intercept is too specific. I don't need that specific of a thing. I need a slope and what?
Point on the line.
A point, any point. It might be the y-intercept, but any point on the line plus my slope. That's all I need. So take a look at number 3. It's real similar to one we finished with yesterday. Notice what we're given in the opening statement, the question stem. It says a line has a slope. Okay, so that's one of the two things I need, right? The slope is 3/8. And passes through,
Negative 16 and 5.
yeah, the point. So I've got a slope and I've got a point that's actually on my line. Those are the only two things I need to find the equation of any line. I got both of them. So this gives us directions. It says write the point slope equation of the line. Let me just remind you what point slope is. Point slope is y minus a y coordinate equals slope, parentheses, x minus an x coordinate. And this is a valid, perfectly good version of the equation of a line. So, based on what we did yesterday, can anybody tell us where we should start plugging in a number? Like, where would one number go? What do you think, Bree? Where could I put one of these numbers?
You put 5 at y1
Put 5 at y1, okay? Why would you pick that?
because it's y1.
Yeah, the y is the y coordinate, isn't it? The 5 is the y coordinate, goes with y1. Agreed. Anybody know what we could have put in place of the m? What do you think, Sophia?
3/8.
Yeah, it comes right out and says slope is 3/8. M stands for slope. Makes perfect sense. And then what would I put in place of x1?
Negative 16.
Say again?
Negative 16.
Negative 16. So wouldn't it be x minus negative 16? Really turns into just x plus 16. So I know in middle school you guys were preached at with slope-intercept form, and we're going to go there here in a second. This is actually a really lovely version of a line. You could leave it just like this, and in fact for A, it's exactly what we ought to do. Just leave it as is. Well, part B says, what's the slope-intercept equation? So this is going to be the same line, same everything, just a different form. Let's remember this. Do you guys remember what slope-intercept looks like in general? There you go. Y equals mx plus b. And you can see that we're going to need to do a little bit of rearranging to get it to that, right? Caroline, any suggestions on what I could do to this to start getting towards that y equals mx plus b? What would be a wise move?
You could, like, I don't know.
Let me give you a hint. Did you notice here on this one that the y is all by itself? What could I do to this to start getting the y by itself? Caroline, let me see if I can give you a little more help. Right now over there on the left side, is the y by itself?
No.
What's with it?
The negative 5.
How do you get rid of minus 5?
Add 5.
You add 5, right? So couldn't I go with, if I start with this, couldn't I just go plus 5 to both sides? So get me started. Okay, so this will give me y minus 5 equals 3/8. Oops, sorry. I added the 5 over. I could go y equals 3/8 times x plus 16 plus 5. So this is starting to look a little more like slope-intercept form, but it's not all the way there. Doc, you have any suggestions on maybe another step that would get this a little closer to slope-intercept form?
Nope.
No ideas.
Yeah.
Do you see any simplification that could be done? Are there any symbols up there that say, hey, math student, do this?
16 plus 5.
Well, the only problem is that's not really 16 because it's inside parentheses. Seriously, it's inside parentheses times 3/8, right?
Mm-hmm.
So I can't just ignore the fact that there's a 3/8 times that whole set of parentheses. But Doc, there's parentheses.
Yeah. So, distributive property?
Yes. I would encourage you all, like I knew you knew that, but you were hesitant. Go with your instincts.
Right.
Hopefully your instincts are good, and most of the time they probably are. And if the instincts are bad, well, we need to fix those. But go with your instincts.
Right.
I felt like you were about to say the distributive property before, but you just didn't. do it. And be right or be wrong, and don't worry about it, because everybody's wrong sometimes. It's okay. Okay, so if I distribute, wouldn't I get y equals 3/8 x partially? What's 3/8 times 16? Isn't it 6? Wouldn't the 16 and the 8 cancel to be a 2? Times 3 is 6? Okay, so it'd be 3/8 plus 6 plus 5. Is this now slope-intercept form? It's really close. What's my final step? Yeah, just add your like terms. Y equals 3/8 x plus 11. This is now the exact same form, this is the exact same equation, just different form of that point slope version of the line. So we just got to do a little bit of manipulation, a little bit of simplifying to get it over to that. How we doing? We're going to keep doing this. We're going to do this to finish off the last couple minutes here today, and we're going to do this for the entire class tomorrow. We're going to keep working at this. Okay, so I want to jump into one more here, like I said, and let's do this one. In your packet, we're going to go past our DMR. I want to do, we're going to go a little ways in here. I want to go to, let's do this one. So find practice 2. Listen, I want you to do this exact one. I don't want you to do something different. Go to practice 2, number 2 for today. Practice 2, number 2. It's up on the screen, so please confirm. I'll try to help. Please confirm that you have the exact same thing I have up there. It should be, the line should be y equals 1/5 x. You got it right there, plus 31. Practice day 15, unit 2, day 15. A couple of other people said that. I don't know. So you just find some space. A couple of folks said that too, and I don't know.
Can I do it right here?
You can do it wherever you want. Absolutely. Okay, so I want to kind of guide you through this a little bit. Like I said, we'll practice this a ton tomorrow. We'll spend the whole time doing this tomorrow. So this says, write the slope-intercept equation of the line that passes through the point 10, 6 and is parallel to the line y equals 1/5 x plus 31. So I'm going to ask you this question. I might ask you again, but I'm going to ask you for sure right now. If I'm trying to write the graph or the equation, please don't just race off. I want to make sure you do this right the first time. So I want to give you a little guidance here. If you're going to write the equation or graph of any line, you got to have two things. What are they?
Slope and a point.
Slope? No, not the y-intercept. That's too specific. I need the slope and any point. It doesn't have to be the y-intercept, although if it is, that's great. But it has to be the slope and any point on the line. Of those two things, which one do I instantly have? I instantly have the point, right? Doesn't it say that my line passes through this point? My line passes through the point 10, 6. So I'll say, the point that's on my line is 10, 6. So here's what I would propose to you. Right now, I have most of this done, and I haven't even had to do that much work. I'm going to use point slope to get started. Think about the word point slope. What does point slope require? A slope and a point. That's why it's called point slope. And I've got a point right here. So what I'm going to do is I'm going to remember point slope is y minus the y-coordinate equals slope times x minus the x-coordinate. And I'm just going to start off.
y1 minus y2 minus y1.
No, it's we're doing point slope form like we just did 5 minutes ago. It's y minus a y-coordinate equals slope times x minus an x-coordinate. Okay? And don't I have my point? So check this out. I could now be like almost all the way done with this. I would say y minus 6 equals some unknown slope times x minus 10. I do not know my slope yet, but I know that point's on my line. So couldn't I write this at least? But what I don't want to have is my slope be m. So I'm just going to erase that real quick and say I've got this unknown slope. But I'm given one key statement, and I'm going to underline it for you. My line is so we just talked about this a few minutes ago. Parallel lines, slopes have what relationship? They're equal. So what's the slope of that line there that ours is parallel to?
1/5.
No, our slope is 1/5. The slope of that line is 1/5. And remember, parallel lines have, like you just said, equal slopes. So what do you think the slope of our line is?
1/5.
1/5. So in place of that m, I'm going to put 1/5. Again, the principle is parallel lines have slopes that are equal. So if the slope of that line is 1/5, the slope of our line has to be the same thing because our lines are parallel. This will be one last chance for us to practice that conversion over to slope-intercept form. Remember, slope-intercept form is y equals mx plus b. Does anybody have a suggestion on what I could do first to get my current equation into that slope-intercept form? Julia, what do you think?
Add 6.
Sure. So if I add 6, wouldn't I get y equals 1/5, parentheses x minus 10, close parentheses, plus 6? So I added the 6 over. Anybody from Bray and Anya and Kate and Trevor's table, what do you think I should do next? Distributive property. Yep, it's the same steps as before. So distributive property there. Clearly it's y equals 1/5 x. But what's 1/5 times 10? It's 2, so it'd be minus 2, wouldn't it? Minus 2 plus 6. Is this in slope-intercept form right now?
No.
What's my last step?
8.
Say Adam, well, it's negative 2, right?
So 4.
So negative 2 plus 6 is 4. This would be my slope-intercept form. Because that was requested, that would be my final answer. Does this feel like something we should spend another day practicing?
Yeah.
Good news, we will tomorrow. Cool. All right, why don't you clear your desks off, grab a fort. We're going to do our quiz on graphing lines. We have been talking about equations of lines, so this should have been a really good warm-up. You're still going to have to do like slopes and y-intercepts. Should be a great warm-up. So please do this quickly so that you have plenty of time. This is a concept quiz. Yep. Retry it.